Bright Tuty. Every student matters.
Hello students, let's start with the chapter Playing with Numbers. So the very first topic that we are going to do is numbers in general form. So suppose I say a 2-digit number, I take 62. Okay, how can I write it? 60 plus 2, or I can also write it as 10 into 6 plus 2. If I take an example of another number, let it be 37. I can write it as 30 plus 7, or 10 into 3, that is 30 plus 7. So all the 2 digits number can be expressed as this, right? So what I want to say is all the numbers would be in the form 10 into a plus b, that is 10a plus b. A is what? Just see here. A is what? The first digit, right? And b is what? The second digit. If you carefully observe, a is the first digit and b is the second digit of it. So we can write 10a plus b. That means if there is a number, there is a 2-digit number ab. Here ab does not mean that a is multiplied with b. A shows the first digit, b shows the second digit of a 2-digit number. So a 2-digit number in a general form can be written as 10a plus b. Clear? Similarly, if I have a 3-digit number, suppose I take 351. I can write it as 300 plus 50 plus 1. That means it can be written as 3 into 100, or I can say 100 into 3 plus 10 into 5 plus 1. Similarly, if you take 273, so we can write it as 200 plus 70 plus 3, also can be written as 100 into 2, that is 200, plus 70 can be written as 10 into 7 plus 3. So if you observe, this is the first digit, let us name it as A, the second digit is B, and the third one is C. So A, B and C are here. So it is actually in which form? 100A plus 10B plus C. So if a 3-digit number is there, this is the general form of a 3-digit number. So what we have discussed, general form of a 2-digit number and general form of a 3-digit number, right? Okay, so here if we see, we have to write these numbers in generalized form. The first one is 25. 25 can be written as 10 into 2 plus 5. Clear? The second one is 73. How can we write it as 10 into 7, that is 70 plus 3. The third one in the generalized form can be written as 100 into A. A is the first digit, that is 1, plus 10 into B, that is the second digit, plus the third digit, that is 9. Similarly, the fourth one, that is 302, can be written as 100 into the first digit, that is 3, plus 10 into the second digit, that is 0, plus 2, that is the third digit. So these are the generalized form of the numbers 25, 73, 129 and 302. Let's do the next question, where it is asked to write the numbers in the usual form. So if we see the first one, it is 10 into 5 plus 6. 10 into 5 is 50. 50 plus 6 gives us 56. So this is a 2-digit number, right? The second one asks us to write 100 into 7 plus 10 into 1 plus 8. We see this is the generalized form of 3-digit number. In the usual form, it will be 700 plus 10 plus 8. So we get 718 as the answer. In the third part, we are given 100 into A plus 10 into C plus B. So first digit is A, second digit is C and the third digit is B. So ACB is the number, is the 3-digit number, right? So this is how we express the generalized form, the numbers in generalized form, or from generalized form into the usual form, right? Moving ahead, we are going to do a game with numbers. Okay, so suppose the first thing that we are going to do is reversing the digits. The first one is reversing the digit, and we are going to do it with a 2-digit number. So there are two students, suppose one is Meenakshi and another one is Sundaram. Okay, so this is the first round that they are playing. So first of all, Meenakshi has asked to choose a 2-digit number, right? And Sundaram then has chosen 49 as the number. Then Meenakshi asked reverse the digits to get a new number, right? So Sundaram has reversed it and got 94. After 49, he reversed the digits, he got 94. Now she is asking, add this number to the number you started. That means 94 is to be added to 49. So he added and he got 143. Then she said that now divide the number or the answer that you have got after addition by 11. So Sundaram has done it and he says that I get 13 is the answer. So Meenakshi already said to him that there won't be any remainder. You won't be left with any remainder. That means the number would be exactly divisible by 11. So he says that you are right, but how did she know? How did she already claimed, like she's claiming there won't be any remainder? How did she claim it, right? So that we are going to understand. Just see here. The 2-digit number, suppose it is AB. And I can write it in the standard form, or I say in the generalized form, 10A plus B, right? Now what is she doing? She is asking them to reverse the number. So reversing the digits, I'll get 10B plus A. Then she asked to add the numbers. So if we add 10A plus B plus 10B plus A. So 10A plus A is 11A and 10B plus B is 11B. Taking 11 common, we get A plus B. So see, it is always going to be a 2-digit number when added to a number by reversing the digits, the number formed. So AB when added to BA, it is always going to be a multiple of 11 every time. Okay, any 2-digit number you can try with, you are going to get it as 11 into A plus B. Now A plus B is what? It is going to be the sum of the digits. A is the first digit, B is the second one. So you add them and multiply it by 11, you will get the answer. Clear? So this is how we do. That's why she claimed that the number would be divisible by, exactly divisible by 11, because it is going to be a multiple of 11 and there won't be any remainder left. So this was the reason that she was claiming. Now here some questions are given. And it is asked, you have to check the result that would have been discussed, that would have been if Sundaram has chosen the number as shown below. So if would have chosen 27, 39, 64 and 17, we have to tell whether that is applicable to this or not, right? So the number that he has imagined in the first one is 27. Okay, now you reverse the digits, you get 72. Now you add them, 27 plus 72. What are you going to get? 7 and 2 is 9, 7 and 2 is 9. 9 can be written as 11 into 9. Is it divisible by 11? Definitely, the remainder would be 0. So let's try the second one. So 39 is the number that he has imagined. Now reverse the number or reverse the digits, you get 93. You add 39 and 93. 9 and 3 12, 1 is the carry. 9 and 3 12 and 1 13. So we get 132, right? 132, can it be divided by 11? Yes, definitely it is exactly divisible by 11. Just to see, 11 ones are 11, 11 twos are 22. So we get 12 as the quotient and the remainder here is 0. So yes, it is applicable to all the numbers. In the third part, it is 64. Reverse it, you get 60. Reverse of 64 is 46. Add 46 and 64. You get 6 and 4 10. 6 and 4 10 and 1 11. 110. Is it divisible by 11? Yes, definitely. And we get the quotient as 10 and the remainder is 0. So now you need to try it with 17. If 17 is the number, what will be the reverse? 71. Add 71 and 17. We get 88. Is it divisible by 11? Yes, it is, and the remainder is 0. It's exactly divisible by 11. So we observe that if there is a 2-digit number, you reverse the number, add both of them, and the result that you get after adding, the sum that you are getting, that will always be divisible by 11. Clear? Let's do something else with the same 2-digit numbers. So here is another question. Just see. So now Meenakshi is saying that think of a 2-digit number, but don't tell me what it is, right? You just imagine it and keep it with you. So he says all right. Now she is saying that you have to reverse the digits of the number and subtract the number. smaller number from the larger number, right? Then Sundaram says, okay, I have done the subtraction. What next? She is claiming that after subtracting, the number that you are getting is always going to be divisible by 9 with no remainder, right? Exactly divisible by 9, that means no remainder would be left. So he says, yes, I am getting that, but how is that happening? So how did she claim that it will be divisible by 9 always? So let us suppose a 2-digit number. So first I'll take any example and then we are going to write it in a generalized form. So suppose a 2-digit number that is imagined is 13. Okay, if I reverse it, I'll get 31, right? From the larger number we have to subtract the smaller number, subtract it. So we get 11, 11 minus 3, we get 8 here. Clear? And 2 minus 1 is 1. We get 18. So is 18 divisible by 9? Yes. So you try with any 2-digit number, this is going to happen, that this would be divisible by 9. But how did she claim for every number? Suppose a 2-digit number is 10a plus b. What will be the reverse of it? It will be 10b plus a. By reversing the digits, we will get this. Now let us subtract it. 10a plus b minus 10b plus a. Right, we could get this. Also we could have got the another one as, just see, 10b plus a, this could be greater, and 10a plus b we can get. Both the things can happen looking on which number is greater. So 10a plus b minus 10b minus a. So 10a minus a is 9a, b minus 10b is minus 9b. You see, you take 9 common, you're getting a minus b. So this is always going to be a multiple of 9. Here if you see, you get 10b plus a minus 10a minus b. So 10b minus b, 9b minus 9a. You take 9 common, you get b minus a. Correct? So whichever number is greater, from that if you subtract, the answer that you are going to get is going to be a multiple of 9. That's why Meenakshi was claiming that if you take a 2-digit number, okay, and when you reverse the number, reverse the digits, then from the greater number you subtract the smaller number, you're always going to get it as a multiple of 9. That's why she said that you are going to left with no remainder when you divide it by 9. Clear? Moving ahead, there are 4 questions given and we have to check whether this results is applicable to these or not. So let us check one by one all. In the first one we are given 17. What will be the reciprocal? Reversing the digits, what will be the number? It will be 71. From 71 we have to subtract 17. From the greater one, the smaller one. So now 11 minus 7, here you will be left with 4 and then you are left with here 6. 6 minus 1 is 5. You get 54. Is it divisible by 9? 54 divided by 9. 9 ones are 9 6. Yes, it is exactly divisible by 9. So it is applicable to this. Now the second question, where we are given 21. Reciprocal, not the reciprocal, the reverse of 21 is 12. From 21 subtract 12. 11 minus 2 is 9. You get 9. So is 9 divisible by 9? Definitely we get 1 is the question. Right? In the third one, it is 96. So reverse the number, reverse the digits, you get 69. From 96 subtract 69. So 16 here, just see, you will take a carry over here. 16 minus 9. You got 7. And then you have here 8. 8 minus 6 is 2 when you subtract. So you're getting 27. Is 27 divisible by 9? Yes, it is exactly divisible and 0 is the remainder. The last question, that is 37. Just reverse the digits, you get 73. So from 73 you are going to subtract 37. Subtract it. So 13 minus 7, we get 6. And here 6 minus 3 is 3. So is 36 divisible by 9? Yes, it is exactly divisible by 9, leaving the remainder as 0. So to all the 2 digits number, that is applicable. Right? Moving ahead. So there is again with the 3-digit number we are going to play a game. So now it's Sundaram's turn to play some tricks. Earlier Meenakshi was giving him the conditions and the situations to write the numbers. Now it is Sundaram. So he says think of a 3-digit number but don't tell me what it is. and then she thought it. Then he is asking that now make a new number by putting the digits in reverse order and subtract the smaller number from the larger one. When you do the subtraction, you have to divide your answer by 99 and you're going to get no remainder. That means 0 is the remainder that you will get. So let's try it with any number. Suppose I take 137 as the 3-digit number. By reversing the digits, I'll get 731. From the greater number, he's asking to subtract the smaller number, right? So 11 minus 7, you get 4. Then you get here 12. 12 minus 3 is 9. And here 6. 6 minus 1 is 5. So 594 is there. You have to divide it by 99. So let's divide it. 594 divided by 99. So let's try it. 3 3s are 9. 3 3s are 9. Then 3 1s are 3. Then you're left with 2. 3 9s are 27. Again 2. 3 8s are 24. Again with 3. 3 1s are 3. 3 1s are 3. 3 6 are 18. 3 6 are 18. 11 1s are 11 6 are. So we are getting the quotient as 6. There is no remainder left, right? So it is exactly divisible by 99. So yes, his claim that he did that it is going to be divisible by 99, that is completely correct. But how he is saying for all the numbers? Let's try with 3-digit number. So we'll write the number in the generalized form. So I'm writing a number ABC. 100A plus 10B plus C. By reversing the digits, the number will become CBA. So it will be 100C plus 10B plus A. Right? Now we have to subtract the number. So let us subtract any number from the another one, because here we don't know which one is the greater one. But with both of you try, like from the first one you subtract the second, or from the second you subtract the first one, you're going to get the same thing. Just see, 100A plus 10B plus C minus 100C minus 10B minus A. So 100A minus A gives me 99A, 10B, then we have plus 10B and minus 10B, they're going to get cancelled. Then plus C and minus, so minus 99C. Taking 99 common, we get A minus C. If from this we subtract this one, we will get, instead of A minus C, C minus A, but 99 definitely we are going to get. So as it is a multiple of 99, so it is going to be exactly divisible by 99. So yes, he was claiming the right thing. Clear? Okay, now this we have to apply to this. Okay, so in the first question they're asking you have to check whatever the result that Meenakshi got after it. So you have to record the quotient also at the end. So 132 is the 3-digit number. By reversing the number, we get 231. This is the reversed number. Now from the greater number, we have to subtract the smaller one. 11 minus 2 gives us 9. Then 12 minus 3 gives us 9, and here 1 minus 1 is 0. We get 99. So 99 is divisible by 99. Yes, exactly divisible, and the quotient is 1 in this case. Second question, the number is 469. When we reverse the digits, we get 964. So after reversing, we got 964. From 964, we're going to subtract 469. So 14 minus 9 is 5. And then here we get 5. So 15 minus 6 is 9. And 8 minus 4 is 4. 495 we get. Dividing it with 99, we get the answer as 5. It's exactly divisible. Quotient is 5. Okay, moving ahead with the third question. It is 737. You know, when we do the reverse, when we reverse the digits, we get 737, and from this if we subtract 737, what are we going to get? 0. Is it divisible? Yes, it is, and the quotient is 0. Okay, the last one is the fourth, 901. Reversing the digits, we get 109. So from 901 subtract 109, right? So here just to see, it is 11. 11 minus 9, you get 2. Here it is 9. Here it is 8. 8 minus 1 is 7. So 792 is to be divided with 99. Are you getting what we have done? 901 is the 3-digit number given. So reversing the digits, we get 109. Then we are going to subtract 109 from 901. So 11 minus 9 gives us 2. Here it is 9 left, and then here it is 8. 8 minus 1 is 7. 792 we are getting. So 99, and we need 2. So at 8 we will try. 9 8s are 72. 7 9 8s are 72, and 7 is 79. Yes, at 8 we are getting it. So the quotient is 8. Clear? Remainder is 0. So yes, that the claim that Sundaram was claiming is correctly done. So now there is again one more tricky question which says, now Meenakshi says that think of any 3-digit number. Okay, Sundaram says I have done so. So let us we also take one number. So let us take 137 only. Now use the number to form two more 3-digit number like this. If the number is ABC, that means this is ABC. That means we have 137. Okay. Now what the first number is CAB, right? With the ones digit shifted to the left hand of the number, right? So CAB we have to form. CAB will be 713 according to us. Okay, and the another number will be BCA. What is B here? It is 3. Okay, C is the next number, that is 7 here, and A is 1. Clear? So we have done fix the numbers like 1 at first place, then 7 at first place, and then 3. Now she is asking to add them up. So if we add them, 7 and 3, 10, and 1, 11. So again here 7 and 1, 10. 7 and 1 is 8, and 1 9, 9 and 3 we get 12 here. Again 1 is the carry, 7 and 3 10, and 1 11, and 1 12. We get 1 2 2 1. Right. Now they are saying that you have to divide it with 37. So there won't be any remainder. So 1 2 2 1 and division with 37. So let us divide it with 37. So with 37 when we divide, let us try. 37 3s are 3 7s are 21, 3 3s are 9, and 10 11. We get 1 1 1. Yes, so at 3 we have 1 1 1. So just see, 2 minus 1 is 1, 2 minus 1 is 1. Here it is 0. Copy 1 from here, 1 1 1. Again at 3 you get 1 1 1. So yes, it is divisible, exactly divisible, and the quotient is 33, and the remainder is 0. There is no remainder left. So yes, the claim is right. So let us try it with journalized form of the numbers. Okay, so according to us, the first number is ABC, that is 100A plus 10B plus C. And the second number that she told is CAB. So if I write CAB here, CAB, so we'll have 100C, okay, plus 10A plus B. And the next number that she said is BCA. If we write that, BCA will get 100B plus 10C plus A. Add them. So what are we going to get? Just see, 100A plus 100C plus 100B. Also we have 10B and C like this. Clear? So we'll write 100A. Okay, then we have 10A. I'm collecting all the terms with A. Then we have A. So adding them, what we get? 100 plus 10 is 110, and 111A plus, again we will get with B also the same thing, 100B plus 10B and B. It also gives us 111B, and 100C plus 10C and plus C gives us 111C. So 111 is common, we get A plus B plus C. Right? 111 can be written as 37 into 3 A plus B plus C. So we see it is always going to be a multiple of 37. Right? So it is always going to be divided by 37, leaving 0 as the remainder. Clear? So this is what generally we have written. Right? So what we were doing in this is, just to see again, we took any 3-digit number. Okay, so the first number, how are they forming the first number? If the number is ABC, the first number is CAB. What we are doing, the last digit, that is the rightmost, is shifted to the left hand. Okay, the other number is BCA, with the 100 digits is shifted to the right end of the number. right? And the number became BCA, like you are forming it. So if we have ABC, what we need to do first, this CAB it will be, then shift B, so BCA, like this the number would be formed. So now we are going to practice some questions that will let you know that this is applicable to all the questions whatever the number has been imagined by you. So the first one is 417. Okay, so let us consider this as ABC. Now what will be the second number? Shift 7 here, so we'll get 7 4 1, and then it will be 1 7 4. Add them all. 7 and 1 8. 8 and 4 is 12. Carry is 1. So 7 and 4 11, 1 12 and 1 13. Again 1 carry. So again 7 and 4 11 and 1 12 and 1 13. 1 3 3 2. 1 3 3 2. Can we divide it with, just see, can we divide it with 37? Try dividing it with 37. So after dividing it, we get 36 as the answer, right? So it's exactly divisible. Now let's try the second question, in which the number is 632. So first is 632. So we will make 2 at first place, then 263, then 3 at first place. We'll get 326. Right? So what we are doing, I am shifting the last term, or I say the last digit to the first place, the last digit to the first place. So let's add them. We get 6 and 3 2. 6 and 3 is 9 and 2. 9 and 2 is 11. 1 is the carry. Again 6 3 2 we have to add, and 1 is also there, so it will be 12. Again we have 12. 1 2 2 1 we have. So we have to now divide 1 2 2 1 with 37. So just try dividing it. What is the answer? By dividing we get, so dividing it with 37, we get 37 only. It's a square of 37. So exactly divisible, 0 remainder. In the third, if we try, the number is 117. So the second will be 711. Then again it will be 171. Getting 7 and 1 8 and 1 9, 9 and 9. We get 999. So 999. Can you divide it with 37? Just calculate what you get after dividing it with 37. So if we divide it with 37, we get 27, leaving no remainder. Clear? Now the fourth part also we have to try. In the fourth part, what is given? 937. So first bring 7. So first bring 7 at one's place and shift these 9 and 3. Now bring 3 at first place, shift 7 and 9. Now we have to add them. 7 and 3 is 10. 10 plus 9 is 19. 1 is the carry. Again 7 and 3, 10 and 9, 19 and 0. 20 we will get. 2 is the carry. So 7 and 3 10, 10 and 9 19, 19 plus 2 is 21. We get 2109, and we have to just solve it like by dividing with 37. So if we divide it with 37, we get the answer as 57. So leaving no remainder, exactly divisible. Clear? So now we will learn the next topic, that is latest 4 digits. So there are 2 rules that you need to take care of, and then we are going to start with some questions, some puzzles we are going to do. So what they are saying here, they are saying that each letter in the puzzle must stand for just one digit. Like if we are using the alphabets A, B, C and so on, they stand just for one digit. Each digit must be represented by just one letter. Each digit must be just represented by one letter. Right? Now, the first digit of a number cannot be 0. Definitely it cannot be. Thus, we write the number 63 as 63 and not as 063 or 0063. Clear? So, 0 should not be the first digit of any number. Clear? So, these are the 2 rules that you need to remember, and we are going to solve some questions. So, if you see here we have to find out Q. So, here it is 3. And something is added into 3 and it is giving us 1 here. Right? So, what can we add here? 8. Because adding 8 plus 3 is 11 and we will get 1 carry. Clear? So I'll just mention here 8. If I mention 8 here, 8 plus 3 is 11, 1 is the carry. So here also it is Q, it will also be 8. 8 and 1 9 and 1 10 and 1 carry over here. 3 and 1 4 and 1 5. Yes, it is exactly fitting into it. So the number is 318 183, and when we add them, just see 8 and 3 11, 8 and 1 9 and 1 10, 3 and 1 4 and 1 5, we get 501. So what is the value of Q here? The value of Q here is 8. So like this thinking, what can be added, what can be subtracted, what can be multiplied, right? We have to think about it and then tell the values of the alphabets that are used here, and we are sure that each alphabet is representing just one digit. Okay, moving ahead, we have another question. A plus A plus A gives us BA. So is there any number that you add 3 times and you get same? So with 1 that happens, but if that happens with 1, just see 1 1 1 we add, we get 3. It is not happening with 1. We don't get the same. With 2 also we will get 6. With 3 we get 9, right? With 4 we get 4 plus 4 plus 4. 12 we will get. When we do it with 5, we get 25. Yes, the unit digit is 5 only, so it is going to be 5. And here it is 5, carry will be 2, so it will be 2, because we can't have this as 0 also. As it is discussed, the first digit will not be 0. So the answer is 25. So value of A is 5 and value of B is 2 here. Clear? Now the next one, this is something multiplication. So here the same digits are there and here it is A. So we have to multiply 3 with something so that we get that digit only here. So that happens with 5. 3 5s are 15 and we get 5 here. 1 is the carry. Now we are getting 57 here. 1 is the carry. Now what should be written here? Just 3. Okay, just think now. So we have BA and B3. So I wrote here 5. It could have been 0 also, because 3 multiplied with 0 will give us 0, right? Then we have here B and B. So just see, if we write 0, so B value, if we suppose it is 575, if we say it will be, or it will be 570. So just see, 19 into 19 if we do, that is 361, and that is less than 575, right? So it should be, it cannot be 1. B's value cannot be 1. Can B value be 2? If it is 2, so if I place here 5 or I place 0, so 20 or 25 we will get, and here it is 23. And if we do for 23, right, we get 529. That is also less than 575, right? So let's try with now 3. If I try with 3, 30 into 30, that gives us 900, which is more than it, right? So what we can do, we can try with 25 just to see. So what we got, 625, that is also more than it. So here we have to think of the digit that can be placed here, because B value is here, B here, B, it is going to be same. Now if we take B as 2 and A as 5, just see, 25 and 23, you multiply it, we get 575. So yes, 575 we can get, right? So A value is 5 and B value is 2 here. Clear? So we are going to practice a lot of questions, right, based on the same, like alphabets would be given, letters would be given to you in place of the digits, and we are going to like this, we are going to do addition question, subtraction question, we are going to do multiplication questions, and we will identify the digits represent which number. Clear? So thank you so much. Stay tuned for more upcoming videos, as in the next session I'm going to give you a lot of practice to the same concept. Thank you.